Look at the first 10 problems of the 2025 MIT Integration B qualifying exams. Problem number 1, which is definite integral of x plus the square root of x all over 1 plus square root of x. Problem number 2, which is definite integral of e to the power x plus 1 over e to the power x plus 1. Problem number 3, which is also an indefinite integral of the cube root of 3 sine x minus sine 3x. Problem number 4, which is a definite integral from x equals to 1 to x equals to e to the power e of the natural logarithm of x to the power natural logarithm of x to the power x all over x squared. Problem number 5, which is the definite integral from x equals to negative pi over 2 to x equals to pi over 2 of the cosine of 20x times sine of 25x. Problem number 6, which is the definite integral from x equals to 0 to x equals to 2 pi of sine x times cosine x times tangent of x times cotangent of x times secant of x times cosecant of x. Problem number 7, which is the indefinite integral of x times natural logarithm of x times cosine x minus sine x all over x times the square of the natural logarithm of x. Problem number 8, which is the definite integral from x equals to 1 to x equals to 2 of 2 to the power x minus 1 plus natural log to the base 2 of 2x. Problem number 9, which is the definite integral from x equals to 0 to x equals to 1 of x to the power 2024 times open bracket 1 minus x to the power 2025 close bracket all to the power 2025. And problem number 10, which is the definite integral from x equals to 0 to x equals to 10 of x times open bracket x minus a half times close bracket times x minus 1. And those are the first 10 problems. In the next video, we'll look at the next 10 problems. So let's begin looking at these problems one by one. So on to problem number 1. So the interesting thing here one would do is to factor out the square root of x from the numerator. So you have square root of x times open bracket square root of x plus 1, and all of a sudden you see that the square root of x plus 1 is the same as what we have in the denominator, and this cancel out gracefully, so that allows you now to just have the square root of x as what you'd want to integrate. And that means that the integral of that problem becomes 2 over 3 x to the power 3 over 2 plus the integration constant. Okay, so that was pretty much it. Number 2, again, one easy problem it was. What you do is you pull out e, and now all of a sudden you're left with e to the power x over e to the power x plus 1, and e to the power x is the same as the derivative of e to the power x plus 1. So all of a sudden you have e times the integral of the derivative of what we have in the denominator here. And knowing that if you have an integral of a function whose numerator is the derivative of the denominator, then that integral is the natural logarithm of the function in the denominator plus the integration constant. So here the function denominator is e to the power x plus 1, so our answer is e times the natural logarithm of e to the power x plus 1 plus the integration constant. The third problem is actually interesting. The integral of the cube root of 3 sine x minus sine 3x. The issue here is what is sine 3x in terms of the elementary sine x or cosine x. I am not good at memorizing these things, so I could just quickly jump and try to figure what sine 3x is, and I know sine 3x is the same as sine 2x plus x, which is sine 2x cosine x plus sine of x times cosine 2x, and then sine 2x is the same as 2 sine x cosine x times the cosine x here plus sine x, and cosine 2x is the same as 1 minus sine 2x squared. And so the cosine x here become cosine squared x, which is the same as 1 minus sine x. And here when I multiply through, I have sine x minus sine 2 times sine 3x. And so the 1 minus sine x here becomes 2 sine x minus 2 sine cubed x, and then bunching up with what we have here, sine 2x plus sine x becomes sine 3x, 3 sine x, sorry, minus 4 sine cubed x. So plugging this here into our integrand, all of a sudden we have the integral of cube root of sine, 3 sine x minus sine 3x is the same as sine 3x minus 3 sine x minus 4 sine cube x. The 3 sine x is cancelled, so we have the cube root of 4 sine cube x, and then this becomes the cube root of 4, pull the cube root of 4 out, times the integral of sine x. And so this just becomes negative cube root of 4 cosine x. And that's the answer that they were looking for. Number 5, the definite integral from x equals to 1 to x equals to the power e of the natural logarithm of x to the power natural logarithm of x to the power x. So using the rules of logarithm, I would pull this power out. So we have the integral from x equals to 1 to x to e to the power e of natural logarithm of x to the power x times the natural logarithm of x over x squared. Again, using the same rule, I'd pull x out. So I have x times natural logarithm of x times natural logarithm of x. And so this x and the x squared in the denominator reduce each other. So we have the integral from x equals to 1 to x equals to e to the power e of the natural logarithm of log of x square of log of x over x, which is the same as the square of log of x times the derivative of the log of x. This 1 over x here becomes the derivative of natural logarithm of x. So as we can see here, this is just as simple as the derivative of the cube of the derivative of 1 over 3, the cube of natural logarithm of x. So the integral being an antiderivative, what it means is that our integral is simply a third, the cube of log x from x equals to 1 equals to x equals e to the power e. Substituting in the limits, we have a third, the cube of log of e to the power e minus a third log of 1. And so log of e to the e goes this side, log of e is 1, since we are looking at log to the base of e. And so we have a third of e to the power 3 minus a log of 1 is 0, so minus 0. And this is the answer that they were looking for. To our next problem, problem number 5, which is the definite integral from x equals to negative pi over 2 to x equals to pi over 2 of a cosine of 20x times sine of 25x. So we're just going to have to use, and this is just a simple identity that one would know, sine of a plus b is equal to sine a cosine b plus sine b cosine a, and sine of a minus b is equal to sine a cosine b minus sine b cosine a. Adding these together, you get twice sine a cosine b being equal to sine a plus b plus sine a minus b. So what this means is our integral is the same as the integral of half of sine of 20x plus 25x, which is going to be sine 45x, plus sine of 25x minus 20x, which is sine 5x. So integrating that, we have a half negative 1 over 45 cosine of 45x minus a fifth of cosine of 5x. And as you can see, these are odd integers, and with the pi here, whatever we have would just go to 0, so the entire integral is 0. I mean, we don't really have to go further and prove it, but since these are continuous functions, we're just going to assume that it's straightforward and the answer is 0. Problem number 6, very interesting problem. The integral from x equals to 0 to 2 pi of sine x times cosine x times tangent of x times cotangent of x times secant of x times cosecant of x. Right here we can see the product of tangent x and cotangent x is 1, but just expressing it in sine x over cosine x times cosine x over sine x, those cancel out and you have a 1, and further 1 over cosine x being secant x, so the cosine x here in the denominator cancels the cosine x here, and then this cosecant of 1 of being 1 over sine x, the sine x here cancels with the sine x, so you have the integral of 1 as your resultant integration, and so that means we have x from 0 to 2 pi, and that means we have 2 pi minus 0, so the answer being 2 pi. Problem number 7, the integral of x times the natural logarithm of x times cosine x minus sine x over x times the square of log x. What I could do is I could divide the numerator by 1 over by x, so we have log x times cosine x minus 1 over x times sine x. As we can see, the 1 over x is the derivative of x, and the cosine x here is the derivative of sine x. So let's express this as log x times the derivative of sine x minus sine x times the derivative of log x over log the square of log x. And knowing that the derivative of a quotient is the same as a quotient u over v is the same as v times du dx minus u times dv dx over v squared, we can clearly see that what we're doing here under the integral sign is we're differentiating the quotient of sine x and natural logarithm of x. So the integral being the antiderivative, so what that means is that those processes cancel each other, and so our integral becomes sine x over natural logarithm of x plus the integration constant, and that's what they were looking for. This problem number 8 is a little bit tricky and longer than unless there's a method that would simplify this. So the first thing I would do is 2 to the power x minus 1 is the same as 2 to the power x over 2 plus the log to the base of 2 of 2x, and I would expand the second part here, or just separate this integral into half of the integral from x equals to 1 to x equals 2 of 2 to the x plus the integral from x equals to 1 to 2 of log to the base 2 of 2x. Expand this part using the rules of logarithms, so we have log 2 or log the base 2 time of 2 plus log of to the base 2 of x, and the log to the base 2 of 2 is certainly 1, so we have the integral of a half times the integral from x equals to 1 to 2 of to the x plus the integral of 1 from x equals to 1 to 2 plus the log integral of log to the base 2 of x from x equals to 1 to 2. And that means that we can now focus on the first here and say let u be equal to x such that natural logarithm of u is equal to natural logarithm of 2 to the x, which means that natural logarithm of u is equal to x times log of 2, and therefore 1 over u du dx is the same as log 2, and so 1 over u times log 2 du equals to dx. And the limits when x equals to 1, u is equals to 2, when x equals to 2, u is equals to 4. So this becomes 1 over 2 times the integral from u equals to 2 to u equals to 4 of 2x being u and the x being 1 over u log 2. So we have u over u times log 2 plus the integral of 1 from x equals to 1 to 2 plus the integral from x to 1 to x equals 2 of log x over log 2. So the log to the base 2 here can be converted to natural logarithm of x over natural logarithm of 2. And that becomes the u's cancel, so we can pull out the 1 over log 2. So we have 1 over log 2 integral of 1 from equals to 2 to 4 plus integral from x equals to 1 to 2 of 1 plus the integral of pulling the constant 1 over log 2, so 1 over log 2 times the integral of natural logarithm of x. This becomes 1 over 2 log 2 u 2 to 4. This actually is x, it's not u, we apologize, and then we have 1 over log 2, and the hidden one here becomes the derivative of x, and using integration by parts, so here we have the 4 minus 2 becomes 2, and then here we have 2 minus 1, we have 1 over log 2. Integration by parts here means we have x log x, and then minus a derivative of log x, which is 1 over x times x, which is now going to be equal to just 1. So we have the 2's cancel here. We have 1 over log 2 plus 1 over log 2 of, on the upper limit, we have 2 log 2 minus 1 log 1, which is just going to be equal to 0, minus the x with limits 1 and 2. So 2 minus 1 is just going to be equal to 1. So we have 1 over log 2 plus 1 over log 2 times 2 log 2 minus 1. And so having that means that we have 1 over log 2 plus 1, and then we have 2 log 2 over log 2 minus 1 over log 2. And so 1 over log 2 plus 1 plus 2 minus 1 over log 2. The log 1 over log 2 is cancelled, so we have 1 plus 2, which is equals to 3. And that was the answer that we're looking for. So on to problem number 9. The definite integral from x equals to 1 to x equals 0 to x equals to 1 of x to the power 2024 times, open bracket, 1 minus x to the power 2025, close brackets, to the power 2025, is, first of all, we have to substitute the complicated part. So we select u equal to 1 minus x to the power 2025, which means that du dx is equals to negative 2025 times x to the power 2024. And if we divide both sides by negative 2025 and then multiply both sides by dx, we have negative 1 over 2025 du being equal to x to the power 2024 times dx. So as we can see, this part times dx can be substituted with negative 1 over 2025 du. But also when you look at when x equals to 0, that means that u is 1 minus 0, so it's 1. When x equals to 1, that means it's 1 minus 1, u is equals to 0. So our integral in the u domain becomes negative 125 times integral from u equals to 1 to 0 of u to the power 125, and dx times to the x to the power 124 becomes du as shown here. So this becomes negative 1 over 2025 of 1 over 2000 times 1 over 2026 times x to the power 126 with limits 1 and 0. So as you can see, that becomes 1 over 2025 times 2026. And that's the answer that was being looked for. This is a very tricky problem, problem number 10. The growth from x equals to 0 to x equals to 1 of x times 1 times x minus half times x minus 1. I would express x as x minus half plus a half, and then x minus half as x minus a half, and then x minus 1 is the same as x minus 1 over 2 minus 1 over 2. And then I can put this closer to this so that we have x minus a half, and then x minus a half minus a half plus a half times x minus a half minus a half. So we have a difference of two squares here. So we have the integral from x equals 0 to x equals 10 of x minus a half, open bracket, x minus a half squared minus a quarter. It's half times a half. And so we can even just go ahead and say let u be equal to x minus a half, such that du dx is equals to 1, and so du can be used substitute for dx. But also at the limits, when x is equals to 0, u is equals to negative a half. When x was 10, u is equals to 9.5. So substituting that in, we get u in place of x minus a half here, and then u squared in place of x minus a half squared. And sorry, this we use, this is du. Okay, so du. And so we have the integral of from u equals to negative a half to u equals 9.5 of u cubed minus a quarter u. And that becomes u to the power 4 over 4 minus u squared over 8 here. And we can pull u squared over 4 out. So you have u squared over 4, u squared minus a half. And then we have our limits applied appropriately. Up here we'd have 19 over 2. And this is a negative a half, negative a half. Applying in the limits appropriately, we're going to get 2025 as our answer. And that's what was being looked for. Okay, so that was it. Thank you very much. If you haven't subscribed to our channel, we do encourage you to subscribe to our channel. We'll continue working on the integration B 2025, since that was completed this past Wednesday. Yeah, so very interesting. Until next time, bye-bye.